Welcome to another episode of Science on the Porch. Today we are going to tackle sources. There it is. How to tell if a source is credible, and how to stop spreading fake news. One of the first things to look at is there a source? You know, if someone shares something, does it have a citation? What are some things that don't have citations? Memes, some pictures, sometimes data. A pretty good rule of thumb is that if you can't figure out who wrote it or who made it, probably shouldn't share it. Next, primary versus secondary sources. So this is kind of like what your English teacher told you to find. You know, find this many primary sources and you can use this many secondary sources in your paper. And you were like, dang it, primary sources are a little harder to find because they're more credible. They're research studies, it's an interview with a person, it's, you know, someone who knows the information firsthand or is the information or conducted the research. Secondary sources are kind of what it sounds like. They are secondary. They weren't there. They're just writing about it. So all the news we watch, secondary sources. Who they interview would be a primary source, generally. Magazines, secondary source. Next, you should think, who's putting out this information? You know, media is biased, as we can all tell. And this little chart kind of helps us understand who leans what way. You can Google media bias online and you'll find a bunch of graphs like this. But, you know, CNN leans left and it has mixed quality to high quality. Fox News, opposite, leans right, medium to high quality. What's the poorest quality on here? BuzzFeed. Don't get your news from them. Vox. One of my favorites, NPR. They're more neutral, lean a little left, but high quality. So a more credible secondary source will cite a primary source. So let's go into primary sources a little bit more. So this is a primary source. This is a research paper out of Denmark on vaccinations and autism. Primary sources will have, you know, background, their objective, their design of their experiment, the results, and hopefully be peer-reviewed. And there will be multiple authors. But still, not all primary sources are equal in validity. You want to look at a lot of stuff. See, even primary studies have different levels of evidence, like level 1. Excuse me, Mr. Level 1 is the strongest. It means there's a solid control group, they had a big population, the study was randomized, which is super important, and hopefully it was double blind. That means that the researchers also don't know which subjects are in which category. Level 2 studies still have a control, and they still decided what they wanted to test and then tested it. It's just their participants weren't random. Level 3 is that they're looking back at something that already happened. So it's not that they proposed an experiment and then move forward. They're just looking at past data. Level 4 isn't as much as an experiment as it is just a report of multiple patients or like subjects who had the same treatment, but there was no control or comparison group. Level 5 is the lowest on the credibility list, and that's expert opinion. It's also a case report, you know, just looking at one individual patient. So whenever you see someone who's like, well, my dad is an expert in the field and he says this, you could say, you know, your dad's expert opinion is only a level 5 in evidence. On the flip side of that, the more experts in a field that you get agreeing with each other on something probably improves the credibility. For instance, 97% of scientists agree that climate change is a real threat. All right, so let's look at this vaccination and autism study, okay? We want there to be a large population in order for it to be valid. Generally, you want it to be greater than 1,000, n equals 1,000. In this one, it's 657,461 children. Spoiler alert, vaccines don't cause autism. You also want to look at who funded the research because that plays into it. This one was funded by the Danish Ministry of Health. That seems pretty legit. The reason that this is important is because, you know, there were some reports that came out on, sugar not being detrimental to your health. And when you looked at who funded that research, it was Coca-Cola. The point is that even in science research, we can kind of design the experiment to get the results that we want if it's not a credible experiment. So some people argue, well, science tells us this one day and then this the other day. But sometimes that has more to do with who's conducting the research and what the goal is rather than the scientific process itself. Next, data. Really all I have to say about this is don't get your data from politicians. So where should you get your data? You should get your data from an accredited institution who's an expert in their field. For instance, Johns Hopkins has been following COVID since the beginning and has been tracking it worldwide. I recommend going on their site for COVID info. Data can be hard to read and it can be hard to interpret. Something to keep in mind is data is almost always an approximation of what the real world amount actually is. Again, this is why population size in a study is so important. This is why you want 6,000 children being tested for autism and not just your 2 kids that happen to have autism who also happen to get vaccinated. Also a reminder that your personal experience doesn't even really make it to like level 5 evidence. That's expert opinion. So unless you're an expert. Well, Becky, what credibility do you have to even be telling us all this? Are you a credible source? You guys are learning so fast. Good question. You should always check your sources. Personally, while I am not an expert, I do have a master's in science communication. So I have studied this material a little more than maybe the average person. However, if you cite me or this video, this would be a secondary source. I forgot almost another thing I want to talk about with research studies is causation versus correlation. So it turns out that the number of killings rises with heat. That same logic, we could say that the number of killings is correlated to ice cream sales. However, we recognize that an increase in ice cream sales doesn't cause an increase in killing. Just they're both correlated because they both tend to go up in summertime. So this is where you need to be a critical thinker. Is there another reason or are there other variables that we need to account for why the Y variable is changing in response to the X variable? A little refresher, your X variable is your independent variable, right? It's what you're testing. So we're testing vaccines, and your Y variable is the dependent variable, and the dependent variable would be autism. Does autism depend on vaccines? So a lot of people like to discredit science because one day it tells us one thing, one day it tells us another thing. What I have to say is that a lot of those same people might not understand fully the scientific method. The scientific method, the first thing that you do is you notice an observation. You notice this and then you kind of want to test why that happens. And so then you make a hypothesis for why you think it happens. And then you start to formulate an experiment. You test your theory with an experiment, right? And then your experiment either has to discredit your hypothesis or support your hypothesis. It never proves your hypothesis. It is very, very hard to prove something in science. But it is pretty easy to disprove something. So it's very easy to reject an initial hypothesis. So what happens when you reject your hypothesis is then you circle back and you realize, this isn't what we thought. And so we need to gather more data and do more tests. So for instance, at first, if we were told, don't wear masks, because we didn't really know a lot about how this virus spread and we were short on masks. And so we wanted to reserve those for medical professionals. But then as we gathered more data, we rejected our initial hypothesis because we learned that the virus spreads through respiratory droplets, and therefore to reduce spread, we now mandate mask wearing. See, this is why it's called a scientific process. It's the same reason why medicine is a medical practice, not medical perfect. If that kind of helps a little. So basically, when you see something on the internet, first of all, if it's an article, like, read the article. Like, theirs is just like. Second, look for a source. If it's a research paper, ask yourself, how many people were in this? You know, how many people did they test? Who funded it? Is this just in one location, or has this been repeated? And really important, was this peer reviewed? That means that peers, who are also experts in the field, reviewed it. That means it's more credible because they were held accountable for their study. And last but not least, are you reading this article because you want to learn, or are you reading this article to just confirm your own bias? And just a friendly reminder that science is not a liberal conspiracy. So thanks again for watching, and if you guys have any other ideas or methods that you use to kind of, you know, weed out fake news, let me know.